Hi, everyone. Thanks for joining me today. My name is Nadine Vogt, and I'm currently a PhD candidate at the Ontario Veterinary College. And today I'll be sharing with you a scoping review of the evidence for the medicinal use of natural honey in animals. And at this point, I'd like to acknowledge my co-authors, Ellen, Andrea, and Jan. This project wouldn't have been possible without their support. Okay, so just briefly, honey has a rich history of use as a medicine. So it's been used as a folk remedy for thousands of years, in different cultures all across the world. It is known to have antimicrobial properties, so is often used and probably best known for its use as a wound healing agent. So it's particularly for infected wounds, but there are a number of other purposes honey was used for as well. Um, and we'll go into that a little bit later based on our scoping review findings. And just a fun fact for the day, honey is one of the few foods that won't spoil as long as there's a low enough water content. So in theory, the 2,000-year-old honey that was found in King Tutankhamun's tomb would have been edible, although I wouldn't necessarily recommend it. So in terms of the rationale behind this work, why did we perform a scoping review? Well, the way medicine is moving these days, we are looking at evidence-based approaches increasingly. So questions like, how effective is honey as a treatment for wounds compared to the standard treatment? That would be an example of an evidence-based question. So we're moving in that direction. And so I will, just so you know, I will be touching on and doing a refresher on what is the scoping review in just one slide. So with that said, there's a lot of research available in the human literature. So if you do a quick PubMed search, if you look at the Cochrane database, there are randomized control trials available examining honey as a treatment for a number of different conditions. There are systematic reviews and meta-analyses available. Unfortunately, we can't say the same for the veterinary literature. There's actually very limited literature available currently. So just a quick refresher, what is a scoping review? What is the purpose of this kind of tool? Well, as it suggests, a scoping review is meant to identify and get the scope of the existing literature, existing published literature on a topic. So, instead of you going out and doing a PubMed search and kind of amassing all the articles on a topic one by one, the scoping review does that for you. So it can provide an overview of the current literature, and therefore it can also be used to identify gaps in the research that currently exist. And then, importantly, it can also be used as a precursor to a systematic review. As a tool to identify, well, is there actually sufficient literature to perform a systematic review, to avoid you going to the trouble of preparing everything and then finding out there's not actually enough information available. So the objective of our scoping review specifically was to identify what is the nature and extent of the current body of evidence addressing the medicinal use of natural honey and or its derivatives in animals. So just to narrow that question down a little bit in terms of our eligibility criteria and talk a little bit more about what specifically we looked at and what we were interested in, our population of interest was all animal species. So humans and insects weren't eligible, but livestock, poultry, companion animals, wildlife, and exotics were eligible for inclusion. And then we also looked at laboratory animals. So these are studies, preclinical trials, so studies looking at mice and rats. So with humans as a target population, we also were interested in looking at that kind of research as well. So in terms of the intervention that was interventions that were eligible for our study, we were looking at natural honey and or derivatives of natural honey. So it had to be produced by honeybees of the genus Apis. There are other genera of honeybees, but we restricted to this kind of more common honeybee type. And we did not look at artificial honey. So there are reasons to suspect that natural honey differs from artificial honey, so we focused on natural honey. So in order to be included, studies had to actually assess the intervention for the treatment or for the prevention of a clinical condition or injury. So studies that were proof of concept, like Could honey theoretically work in this situation? Those kinds of studies weren't eligible, and also pharmacokinetic studies were ineligible. So in terms of what information sources we consulted and what our search strategy was, so we looked at a number of different electronic databases listed there. We also looked at the grade literature, looked at theses and dissertations and Google Scholar. And then to make sure we weren't missing any major studies in this field, we performed reference list checking on 50 of the most recent articles that were included. I don't have it listed here, but our search strategy essentially comprised honey and various kind of iterations of that, and then intervention or treatment or that sort of thing. For the screening of articles, as recommended, we performed this independently with 2 different reviewers, and then any disagreements that came up were resolved by consensus. There were 2 levels of relevance screening. So the first level was just looking at titles and abstracts, and then the second level was looking at the entire text for relevance. So in terms of what we found, the total number of articles identified by this review was approximately 20,000 between electronic databases and other methods of the gray literature. And then when we kind of went through and deduplicated, excluded records that weren't relevant, we ended up with a total of 397 publications that were included. Most of those were primary research studies. So we only had 1 systematic review, but most of those publications were primary. I will just mention and point it out here that of the records that were excluded, there were quite a number that were not in English or French. 64 articles. Most of those were actually in Spanish. We did not have translational services, so we weren't able to capture those. So that might be something to consider for future studies in this field. So if we look at the publications that were included in this work, what you'll notice, so we have 397 in total. The way it breaks down with veterinary versus the biomedical research that's intended for human purposes, most of the research was biomedical. We had 350 publications in that field, whereas we had 47 looking at veterinary applications. So you'll notice that some of the publications had multiple studies. That's why there's some extra numbers there. Some were reporting more than 1 study, so we reported those numbers separately. So we had 49 studies in the veterinary field, and we had 388 in the biomedical field. When we look closely at the veterinary research studies, most of those are case reports. We had 23 case reports or case series. We had a couple of controlled trials. We had 8 of those, and then 18 challenge trials. So just a quick refresher about challenge trials, that's when disease is deliberately induced, so not natural disease. So for example, in wound healing, if that was the indication of interest, wounds would be deliberately created and then treated with honey. And so what you'll notice for biomedical research is those are all basically, that's what we found for biomedical studies. There were exclusively challenge trials with the exception of 1 systematic review that was identified. Now, if we look at a map of where that research is coming from, we had a total of 45 different countries that were represented by this work. And so it's colored by the density or the number of studies that were identified in that particular country. And so there's 2 countries that really stand out there that had over 40 publications each, most of that being biomedical research, but those countries were Iran and Malaysia. And then we've got a couple others that are a little bit more kind of darkly colored, like India and Turkey. And the remaining countries, most of them had fewer than 10 studies each. So, you know, quite marked differences depending on what part of the world you're looking at. Now, if we look at the publications that came out in different years, so we've got biomedical research in red, and we've got veterinary research in kind of turquoise or blue, and biomedical research, obviously we have more of it, but the number of publications began to increase a little bit earlier, maybe starting around the year 2000, whereas veterinary research really started taking off in the year 2010, so only about 10 years ago. I will just mention though that the line, although it decreases in 2019, our study, our search was performed in September of that year, so we can't conclusively say that the research has, decreased the way it appears in this graph. So just a bit of caution in interpreting that image. So when we look at the different species represented in this work, there are a number of different species in both fields, in both veterinary and biomedical. I don't have a comprehensive list here. This is just to give you an idea of what we were finding. For veterinary studies, dogs and cats were studied often, in addition to livestock like domestic cattle. We had horse and donkey studies as well. Quite a few horse studies, actually, looking at wound healing and looking at like lower limb injuries specifically. And then for biomedical studies, not surprisingly, most of those were in rats. We had some mice studies as well, and then fewer rabbit and dog studies, but those may be considered applicable to the veterinary field. So I've got lots of indications listed here, and this is not comprehensive. There were pages and pages of indications. Many different body systems were represented. So I have some of them listed here just to give you an idea of some of the things that we were seeing. By and large, most of the studies were examining wound healing. So I've got wound healing under that. Burns is included. There's a lot of research looking at that specifically. Other kind of less commonly studied indications were like post-enucleation wounds, contaminated fractures, and then some kind of interesting applications like foot and mouth disease. Bovine digital dermatitis. And then I'm not going to go through them all and list them one by one, but we have gastrointestinal body systems covered, toxicities, metabolic, lymphatic, and immune. An interesting one under lymphatic was the treatment of parasitic infections like trypanosomes and schistosomes, Toxoplasma gondii as well. Urinary systems, the treatment and prevention of neoplasia and metastases, and then finally ocular indications. So topical application of honey to treat things like corneal injuries and dry eye and keratitis. So quite a variety of indications beyond just wound healing. So in terms of the interventions, we classified honeys into kind of major groups: medical honey versus non-medical honey. So this was meant to kind of capture honeys that are standardized, that are commercially available, versus ones that may not be standardized. So you may recognize MediHoney there. So theoretically, one study looking at MediHoney should be, comparable to another study that's also looking at MediHoney. That's the reason we did that. So most studies were actually looking at non-medical honey. And these came from a variety of floral sources. We had a lot of studies looking at Manuka honey coming from New Zealand. And then because Malaysia was a major contributor, we also saw studies looking at tualang and jalam honey. So a number of different floral sources, but we also saw that honey was administered in different ways. So sometimes honey was administered as the sole treatment, and other times it was, used in combination with other things like propolis. So other, potentially medicinal compounds derived from bees as well. And herbal compounds were frequently used. So one of the most interesting things that I learned while doing this project was that there are so many different ways to process honey. Honey can be given or can be unprocessed. So it can be raw, it can be filtered like you see in the image there. Filtration removes some of those compounds that are naturally found in raw honey, like bee pollen, to give it a different texture, to allow it to be more liquid and less crystallized. Irradiation is also another way of processing honey. So, there were so many different ways of processing. So another potential source of heterogeneity, and something that should be considered for sure in future systematic reviews looking at honey. So unlike pharmaceutical agents, which have a standardized compound, natural products are a bit more challenging because it can really vary depending on what season and method of processing and floral source. So there's just so many different things to consider when looking at how comparable is honey from one study compared with another study. So to summarize the veterinary literature, again, we saw a total of 47 publications. It does seem to be increasing in the last 10 years. Or that's roughly when it started, but it does seem to be increasing. And roughly a third of this literature was focused on wound healing in equines. So equines, including both donkeys and horses. And most of those were actually challenge trials. So, take home message is that the veterinary research is definitely lagging. So we didn't find as much work in the veterinary field, compared to what's available in the human and biomedical research fields. And on top of that, most of those studies are case reports. So we definitely need more primary research. We need more controlled trials assessing honey in natural conditions, natural disease conditions in the field. We identified the possibility of a wound healing systematic review in the equine field, looking at those challenge trials that were identified, but it wasn't in the scope of our research project to examine whether that would be possible or not, but it might be something that other researchers may consider in the future. And then, as I mentioned, most of the veterinary work is focused on wound healing, but from what we saw in the biomedical literature, there's a whole spread of different indications that honey might be useful for that should be examined in the veterinary context. So, for example, mastitis, fractures, parasitic infections, gastric ulcers, and so forth. So in terms of future research, what directions, we suggest that things move based on our findings is that as I continue to harp on, we definitely need high quality primary veterinary research. We need those control trials. We need to be able to assess the efficacy of something like honey under real world conditions. And then, we need to address those research gaps that are existing in regards to the different types of honey. So we need to be able to compare different studies. We need to better understand how raw honey compares to processed honey. How does irradiation and filtration impact the medicinal value of honey? So our suggestion for future work would be to focus on standardized medical grade honey. So that ensures comparability between studies. And then, if possible, to assess non-medical grade honey in addition to the medical grade honey, and then use a common control group so that that comparison can be made. Obviously, if the indication allows for that placebo treatment. So we did have a number of limitations with our work. Quality assessments aren't typically performed for scoping reviews, but it's something to think about. We look at what literature is available, but we're not actually assessing what quality that work is and whether there's a potential for bias in the study designs of those works. In addition, electronic searches have their limitations, so we may not have identified all relevant articles. And then, of course, as I mentioned, we did exclude articles based on language, so we didn't include those articles. So in the future, something to consider would be to include language translation services to avoid that issue. So I'd like to acknowledge a number of people and organizations for their help with this work. Christopher Popovich, Catherine Smith, and Christian Stevens. Although there was no external funding for this work, but I would like to thank stipend funding for my PhD research. And thanks for tuning in. Happy to take any questions, so feel free to email me or contact me.